They're still in that. Yeah, they're there.
Probably wouldn't last 5 minutes.
So we're going to talk about centripetal motion today, and centripetal is kind of a spinning type of motion. Sometimes on the rides when they say that the bigger person has to be on the outside if you're in there with two people, do you know why that is?
I'm thinking if it's pulling towards the center that somebody may get hurt.
Yeah, okay. If the bigger person is on the inside, then that kind of forces them out, and they're going to squish that other person. So centripetal force, the important thing to remember is that it always points towards the center. And forces cause, do you know what forces always cause? Acceleration,
yes.
Right? Acceleration. So this video is really about centripetal acceleration, and that also points inwards. If it, acceleration is a vector, right? So it has that direction. The direction for centripetal acceleration is always going to be to the middle of the circle. Okay? So we're going to talk about an equation that we have for that. And if you'll write this down for me, Mrs. Townsend, the first variable in our equation is AC. Okay, and it's A with a little c. So we want to distinguish that acceleration and centripetal acceleration are not exactly the same. Centripetal acceleration is a very special type. So A with a little c stands for centripetal acceleration. Okay, so you have centripetal acceleration, and the units for that
is meters per second squared because it's still acceleration.
That's cool because I can remember that. I already know that from all those other equations. Okay, and then the next one we have is, you want to just put the units there for us? Meters per second squared. And then the next one we have is VT. Okay, do you remember what V is?
That's velocity.
Okay, so this is, again, a special kind of velocity called tangential velocity. Do you know what a tangent is?
I remember it from geometry.
Okay.
And it was on the circle, and it's that straight line that touches the circle.
Right, okay, so you were talking about like if you had something swinging and you just let go, does it keep going in a circle?
No, it'll like fly off. So like when you're driving in a car and you're going around a curve and you let go of the steering wheel, what's going to happen?
You're going to shoot off in a straight line.
Yes.
That is a good example of tangential velocity. But it's still velocity, so we're going to measure it in
meters per second.
Okay. Yes. It's a radius, but a radius is just a special type of distance.
Yes.
So that's going to be measured in meters. So we have all these little special cases, but it's already stuff you guys already know. Radius is a distance, tangential velocity is just a special velocity, and centripetal acceleration is just a special acceleration. And can you write our equation down for us? We're going to have AC equals VT squared, and don't forget the square, guys, that's very important, over R. Hey, Miss Townsend, what are we going to talk about today?
Centripetal acceleration.
Acceleration, and this is guided practice, right?
Yes.
Let's look at number 1. So a young boy swings a yo-yo horizontally above his head. So we're talking about something like this, swinging around, okay? And that yo-yo has a centripetal acceleration of 250 meters per second squared. If the yo-yo string is 0.5 meters long, what is the yo-yo's tangential velocity? There is a lot of words in that. Can you help me break this down?
Yes. The first thing that we need to do is we need to go through and look at our variables. It says that when I looked at my units, I saw meters per second squared.
That is acceleration, right? Okay, so should we write that down?
Yes. So we have our A equals 250 meters per second.
A little tricky.
Meters per second squared.
Okay, and I see 0.5 meters.
0.5 meters. What does that unit meters tell you?
Meters. I know we have meter sticks. So isn't that distance?
Yes.
Okay.
Distance.
Okay. And then tangential velocity. I know you guys just talked about that. We talked about that in the notes. That was like kind of like linear velocity, right, in a straight line. And we write VT.
Yes.
Okay. So VT, and that's what we're looking for. So that's our question mark.
Yes. I had a professor once who told me that the tangent would be like if you're driving a car and you go around a curve and you let go of the steering wheel.
And you just fly off.
Fly off, you go straight.
Okay, cool. All right, so that's what we're looking for. And so we have our equation, an equation that has A and VT in it that we just learned. It's A equals VT squared over R.
So I'm going to write the...
Put a little C because it's centripetal, right?
Yes.
Okay. Now, I'm a little bit confused because we don't have an R. We have a D.
Yes. And if you remember back in geometry, what a symbol is R?
Isn't that radius?
Yes, it's radius.
Okay. Oh, and the yo-yo string, when you're swinging it, is the radius.
Yeah.
But
Because
that's
it makes
also
a
the
circle.
distance.
Yeah, it makes a circle.
Okay.
Okay.
So if I see a distance and we're talking about centripetal acceleration, I can kind of maybe assume it's the radius?
Yes.
Okay, so that's R. Okay, so then do we just plug in?
Yes, we can just use the numbers that we just wrote down, and we're going to plug them into our variables. And so A was 250, so I'm going to write underneath this. I'm going to put them in just as my formula is, 250
Okay.
equals,
VT we don't know, so we just leave that alone, right?
yes. But I'm still going to write it in there. A big mistake that I'm seeing is a lot of people, they'll put X because they're relating it back to their math. And so if it's unknown, they're calling it X, but then they're getting confused in units, and they're also not carrying over the square. So rewrite it just as your formula shows.
So the X really doesn't mess up the number, but it messes up your units.
Yes.
And then if you drop the square, that's going to mess up your number too.
Right.
Okay, so over 5? Right? Because you just said distance and
Yes.
radius are the same? Okay, so now we just have to do the algebra, right?
Yes.
Okay, so I think I'm going to multiply by 5 on both sides, right?
Right, because we want to do the opposite. So right now it's dividing by 5.
Okay.
And so I don't want it on this side. I want to isolate that variable, and so I'm going to multiply by 5. So 5 divided by 5 is 1, so it doesn't change my equation. But I have to make sure that I multiply by 5 over here on this side.
Okay, so when I multiply that in my calculator, I get 125. So I'm done, right? 125?
No.
It says VT squared is 125. Wait, what's the deal, Miss Townsend? I think that should be the right answer. What's wrong? What do we still have to do?
I made a mistake and didn't put 0.5. I just put 5.
Oh,
So I'm going back and putting my dots because I'm thinking probably the same thing you're here. 5 times 250 is not 125.
I put 0.5 in.
Yeah.
Okay, so now I got to
Okay.
figure it out. So it's a 125, right?
Yes.
What do I still have to do?
Well, I've heard people say we need to unsquare it.
Unsquare. Oh, I got to get rid of that squared.
Yeah.
I don't know what unsquaring is, but I do know about square roots. Is that what we need to
Yes.
do? Okay.
And if you look on your calculator where it says x squared, right above it is the square root. So it's the opposite of
Okay.
it. So if you're still confused, look at your calculator to see what the opposite functions are on your calculator. So if it's squared, the opposite is to take the square root.
Okay.
Okay? So we're going to take the square root of both sides.
And when I do that, I get 11.2. And my units, because we left it as velocity, not x, velocity is in meters per second.
Yes. Meters per second.
Okay. Is there another way to do this? Okay. So you're going to show me a different way. So we still need our equation,
Yeah,
right?
I'm going to put the equation back. I didn't mean to erase that. Okay. Same equation.
Okay, but we're solving for VT, so
I want to isolate my variable. And remember, if I isolated you in the classroom, I would be like putting you in the corner away from everybody else. So you're all by yourself. So I want that all by myself.
Mm-hmm.
So to do that, I have to basically what we call get rid of the other variables. And right now, R is on the bottom, which means to divide. So I want to do the opposite. So I'm going to multiply by R. And so R divided by R is 1, so it doesn't change that side. So I'm going to come over here on the other side and multiply by R.
now, Miss Townsend, I remember something you just told me. I'm also going to have to take the square root, right?
Yes.
Okay. So square root first, no, next, I'm sorry. So that we can write it with VT is equal to R times AC, the square root of R times AC. And so then this time, because we did that first, now we can just plug in the numbers as is, right?
Yes.
So we have 0.5, the square root of 0.5 times 250. And if we stick that in the calculator, we get 11.2, right?
Yes.
So same answer, 2 different ways to do it. You pick the one that works for you.
And are the units still the same?
Yes, ma'am, because we're still finding velocity, meters per second. All right.
Okay.